So lecture 5 is on graphing compound inequalities, and the idea here is that if we have a combination of inequalities, we can combine them and we can try to either graph the set of x values that satisfy these inequalities, or we can use interval notation. And let's do a bunch of examples to show how to do this. So for example, let's say that you had these two inequalities. So x is less than or equal to -2, or x is greater than -1. So let's try to graph both of these. So x being less than or equal to -2, if we start to draw this out on a real line, what will we have? Okay, so x being less than or equal to -2, we will put a solid circle for -2. And then, you know what, let me switch to a different color here. So let's say red. Okay, so solid circle here. And we're going to be x is less than or equal to this, so the x values would be over here. Or we're going to have x is greater than -1, strictly greater. So let's put -1 here. -2 we could write in red as well, it doesn't really matter. But then the x values are going to be greater than -1, so it looks like this. So that's how you can represent this graphically. How would we represent this using interval notation? Okay, so we can represent this interval over here as -∞ to -2. And since this is including -2, we're going to use the bracket. And this interval here we can represent as -1 to infinity. And we have an open parenthesis because we're not including -1 there. But how do you combine these together? Well, the word or, symbolically, we can use what's called the union. Okay? And it just translates the word or, essentially. So it's this collection or it's this collection. So the notation for this, is a U for union. So we'll put a little U here, like this, meaning you're either in this set or you're in this set. All right, so what about this example here? So we have x is less than or equal to -2, and x is strictly greater than -5. So here we're combining these with an and. So let's see what happens in this situation. So first let's draw out a number line again and try to graph these separately. So if you have several inequalities, you could try to graph them on a real number line, and that'll help you to get what the interval notation might be. Okay, so -2. So first, we know that we're going to have to draw in a -5 and a -2 in here, so it might make sense to realize where each of those are going to lie on the number line. You know, if you put the -2 over here, then we know that we're going to have to put the -5 over here. So just, maybe just quickly check what values are you going to be plotting there. So -2, this is going to be a filled-in circle because we're including -2, and x is going to be less than or equal to this. So that's this region over here. Okay, so that's the red. Now let me switch to a different color for this other one. So let's switch to maybe green. Oh, you know what? Let me switch to maybe a purple. How about that? Okay, so now if x is greater than -5, so we'll plot -5 here. And then we're considering x values that are greater than this. Okay, what you could actually do, you could put them on the same number line like this, or you could write them on separate number lines. But the key thing here is this word right here, this and. Okay, so what's happening with that? Well, what we mean is we want the x values to be in both of these. Unlike up here with the or, which was a union, we're going to be in one or the other. When you're saying the word and, you actually want to be in both. You want to satisfy both of these inequalities. When you're saying or, you want to satisfy this one or this one. So down here, there may be actually situations that you satisfy both in the or, but with the and, you want to satisfy strictly both of them. Okay, so how do you write that in terms of the interval notation? Well, you could actually start out the same way that we had up here, but even quicker. Do you see that with and, you're just kind of looking at where these things actually overlap? So the real picture kind of looks like this: -5 to -2. So really just filling in where the red and this purple are overlapping, and you're getting this interval here. So that interval, well, using our notation, we could, well, we would just write -5 and use an open parenthesis because it's not including that. But instead of going to infinity, well, we stop up here at -2. And we would use a bracket to close that off. So that would be our answer, actually. Another way that you can represent this is the word and. This is intersection. So now we're kind of getting into a little bit of the set theory here, but the notation for this is, it sort of looks like an upside down union symbol. So that's just, when you see the word and, that's an intersection. You want to be one and the other. The x values that are in this region right here satisfy both inequalities. So for example, -3 is a value in here, and -3 is less than or equal to -2, and -3 is greater than -5. Okay. Also, using this intersection notation, so following kind of the same procedure that we had up here, you could actually do the same thing. You could write out both of them separately. So maybe I'll just show you that real quick. You don't have to do this, but I'm just trying to be sort of consistent with what we did above. So this red one would look like this. That would be from -infinity to -2, right? But we're going to include the -2 actually. So you know what? Let's switch that to a bracket, right? So we're including -2. And then the purple one, what is that? So this becomes -5 to infinity. And sort of this notation here is sort of the operation that connects these two intervals together. So when you intersect them, you will get this answer down here that we already got. Okay, so this is the answer. I'm just trying to show you how you can actually do the same thing that we did up above. But it's much easier, and to me at least, to stick to the graphs and try to help you solve the problem that way. Okay, so continuing on, sometimes compound inequalities can be given to you in this way right here. So this is already kind of sort of satisfying an and, right? We're actually saying -1 is less than or equal to x, and x is less than or equal to 3. So it's already a compound inequality. But you can graph that just like we did up above. So what would that look like? So we would have a real line. All right, and we could switch colors here just to make it a little easier to look at. So what do we have? We have a -1 and a 3. So -1. Now, since we're including -1, we want to fill that in. And 3, we're also going to include that, so we'll fill that in. And then we're going to look at all the values that are in between these two. Okay, so that's a graphical representation of this compound inequality, but what's the interval notation? Well, it's -1, and we'll put a square bracket there because we're including it, and 3, square bracket because we're including that. So not too bad, especially if you look at the graph versus sort of this symbolic representation. Okay, how about this one down here? So -5 is less than x, and x is less than or equal to -1. So again, this is like a compound inequality with an and in it. It's sort of just hidden there instead of separating them. So it's a little bit less involved than the one that we just did. But if you try to graph this, you could go directly to the interval notation. I'm just trying to get you used to seeing both of the representations. And for some folks, it's a little easier to work with the graph first. So we have -5 and -1. So -5. Now, are we going to fill that in? Well, no, because we're not including -5. And -1, are we going to fill this in? Well, yes, because we're allowing x to be equal to that. And so this compound inequality is saying x is between these, right? So that's satisfying both of those inequalities. So that would be this right here. Okay? And so that would be this interval. So -5, open parentheses, and close like that. Now, just to kind of reinforce what I was just saying, this is actually a compound inequality. This is actually saying -5 is less than x, and x is less than or equal to -1. So you see how you can actually go in both directions, right? I could convert this into this, and I can convert this into this. However, you have to be very careful when you're going from from the right to the left. You really have to be careful there, because in this instance, right, if you draw them out carefully, you will see we'll get a similar solution to what we actually had above. If you want, I could show you that real quick. If not, you could just skip ahead. But look at what this looks like. So we have our real line, and the first inequality. What would that look like? So let's say that I gave you this instead. So you could draw in -5, and x is going to be larger than that. So that first inequality looks like this. What about the second inequality? The second inequality, so maybe switching to another color here. So -1, we're going to be over here. So -1, and all the x values are less than or equal to that. And then now the and means that's the overlap. So what is the overlap between the red interval and this blue interval, right? Well, we're getting this interval right over here. So the overlap would look like this, right? It would be -5 up to -1. So we're getting this right here. So maybe that helps a little bit, so you can see how you convert from one to the other, but it also reinforces the fact that this really is a compound inequality. Okay, so how do we solve compound inequalities? Well, you're going to use techniques that we just did in the previous section, where you solve the inequalities. You're just solving several of them, and you're going to combine those solutions together. So if you had something like this, well, if you did them separately, what would you do? So if you pretend that this right one isn't there, well, we're going to try to isolate the m, right? So what would you do? You would subtract the 1 over to this side. If you pretended that the left side wasn't there, you would actually do the same thing. You would subtract 1 to this side. So when you have these compound inequalities like this, you can actually do that action just like you did before, but you're going to do it to all parts of the inequality. So we want to isolate that m. So in order to do so, let's get rid of this -1. Let's subtract 1 to at all sides of the inequality. So you see we have an inequality portion here, in the middle, and over here. So we're going to have to subtract 1 from all those parts. And if you do that, well, we'll get -4 less than or equal to m, right, because this part will cancel. and 3 minus 1 is 2. And we're left with this compound inequality. And we could graph that or go directly to the interval notation. But just so we get some practice, let's draw that in. So you know what? Let me switch to a purple real quick to draw the number line. Okay, so we'll draw the number line. Okay, switch back, and what do we get? Okay, so -4. And are we going to fill this in? Well, yes, we're allowing to include that. And m is going to go up to 2, and we're also going to fill that in because we're including 2. So that's the graphical version of this compound inequality, right? And what does that look like in interval notation? Well, -4 inclusive with the square bracket, and 2 inclusive with the square bracket. And that's it. All right, well, how about this one? Well, you're going to start this one just like we did any of the other ones. We are going to try to isolate that x so we can figure out what x values are going to satisfy the inequality. So how do we proceed? Well, we're going to multiply all parts of this by 4, right? So multiply by 4. So let's not forget divided by 4 here. Okay, so if we multiply by 4, so we'd get -4, but then 0.25, that'll make it a -5. And then the 2x plus 3, because we're multiplying by 4, so those are reduced. And 3/4, right, 0.75 times 4, so we'll get less than or equal to 3. And then at this point, what do we want to do? Well, we're trying to isolate that x, so we're going to have to get rid of this plus 3. So let's subtract the 3 to all parts of the inequality here. So we'll have a -8 less than or equal to 2x. The 3 cancels this, and 3 minus 3 is 0. So we're getting closer, so we want to isolate this x. We're going to have to divide by 2. So thankfully, we're dividing by a positive, so we're not going to have to alter any of these inequalities, right? So if that happened to be a -2, we would have to swap these inequalities, but we're not doing that. So we have a -4 less than or equal to x less than or equal to 0. And it looks like that's the solution, but we want to represent that in interval notation. So let's do that with both graphical and interval notation. So graphically, this would look like the following. So we would have -4, and we're going to include that, and we're going to go up to 0, and we're going to include that as well. So since I didn't use any color, let's make that really clear. Right, so we're talking about that, and the interval notation would be -4 with a square bracket, 0 with a square bracket. So that would be the answer. Okay, so let's continue to some other compound ones. So in this case, here we have some compound inequalities, but they're separated. So we would solve them separately and then combine the solutions at the end. So we could have theoretically done that above, but that's not the way it was given to us. So let's proceed here. So we're going to solve these separately. So what do we do here? Well, we're trying to isolate the x as always. So let's bring the 5 over here. So let's add 5. So we're left with 2x on this side, the 5 and the -5 cancel, less than or equal to, and that'll be 4. Okay, so that's one of them. And then what happens over here? Well, we're going to add the 6 over to this side. And what are we left with? Well, minus 3x, and the 6 and the -6 cancel, less than or equal to, what is this? So minus 9, right? Okay, so at this point we're still solving these separately, right? So divide this by 2 to isolate the x. So we'll get x less than or equal to, and we're dividing by a positive, so we don't have to swap that, but that gets 2. And so that's the solution for this first inequality. What about the second one? So or. So you might as well just carry the or down just so you don't forget that these are separate inequalities with their compound. We're going to combine them. And here we're going to have to divide by -3. So if we divide by -3, we're going to have to be very careful, right? Dividing by a negative. So we will get an x, but because we're dividing by a negative, we're going to have to swap this, right? Change that so it's x is now greater than, and then this will just be 3, right? So negative over negative is a positive, and we get a 3. Okay, so here is our compound solution, but we want to represent that in interval notation. So let's do this with the graph first, right? So let's let me switch colors, so hopefully this is a little nicer looking. Okay, so there's our real line. So let's graph that one. So x is less than 2, less than or equal to, right? So x is less than or equal to 2. So that would be this region here. And then we're also going to consider x is strictly greater than 3. So we're not going to fill in that circle, but we're going to be in this region here, right? So when you're dealing with ors, you're not looking just at the overlap. You're saying you can be in this part or this part. There actually may be overlap between those two, but in this situation, right, where a solution is, well, you could be over here or you could be over here. So the way that we'll write this in interval notation, so write out this interval, -infinity to 2, and this is filled in, so we'll use a square bracket, and the or converts to this u for union, right, and we'll have an open circle, open parenthesis for the open circle, up to infinity, and that's our solution. That's the solution for the interval notation. That solves this. And at the end here, I just thought of an interesting extra example that I could give you to kind of show you a situation when you could actually have an or and there's actually some overlap here. So I wanted to just show you the difference between what would happen if we're talking about an intersection versus a union in a situation like this. So let's say that I had two inequalities, right? X is strictly, well, x is greater than or equal to 2, and x is strictly less than 3. Okay, so let's see what happens if I combine these two with an and or an or. Okay, so here's the graphical representation. X is greater than or equal to 2 would be this solid blue area, and x is less than 3 would look like this red region over here. Now, if we combine them as an and, what would this look like? Well, we're considering where these intersect. So we want to be in both. So that would look like this, right? So you're looking at the overlap there. So that would be sort of the graphical version of the intersection of these two. And how would you write that as an interval? Well, that would look like 2 to 3, and we would have a bracket on the rectangular, closed bracket on the 2, but an open parenthesis on the 3. Now, if we were considering the union of these, remember, union is just you have to be in one or the other. So you could be in the red or you can be in the blue. Now, we're not talking about the overlap. We're just saying you have to be in one of those. Well, think about this. If you were over here, like let's say you were 0, you would definitely be part of the red part. If you're in the middle, well, you're definitely part of one of them. You're actually part of both of them. So, for example, 2.5 is still a solution to this because you are in here or here. You're actually in both, right? And if you're greater than 3, let's say you're over here, and maybe 4, then you're part of the blue. So the union in this situation would actually be the whole real line. See this? So remember, union is just you have to be in one or the other. So if you arbitrarily pick an x value right now, you're certainly going to satisfy one or the other of these. There's no x value that does not satisfy. It wouldn't. There's no x value that wouldn't work here. So what does the interval notation look like for that? Well, the solution is all real numbers. So you would have from negative infinity to infinity. And another way to write that, another notation, also could write this notation here. So sort of an R with an extra line there. So the all real numbers. All right, but that's the interval notation. So there you see a situation where you do have overlap, but when you do the or, you're going to get the whole. You could get the whole real line if you have overlap. That's not always going to be the case, but here's a situation when you do have overlap and you get all real numbers. So thought you might find that interesting, just comparing that to the last example.